Okay, we're talking about section 1.2, applications of the linear equations. So all of these are some sort of reading type problem where we set up our own equation, and then they should all be linear, and then we solve in the last. It's a concept question, and it says if you have two solutions, one is concentrated at 50%. 50% of whatever is in this bucket is pure acid. In another bucket, you have a 60% concentration. So if you were to mix those together, you don't get 110% of it. What happens is it mixes together to be somewhere between 50 and 60, because the one will dilute the other one down, the other one kind of strengthens the 50 up, and they meet somewhere between 50 and 60. So that's how we do these mixture problems. When you're mixing two concentrations, the answer is somewhere between the two percentages that you get. So the first question is, which of the following could not be obtained? So we could get 55, 58, and 52. All of those are somewhere between 50 and 60, but 64 could not happen. You can't mix a 60% concentrated something with 50% and get up to 64. It'll just be between those two. So 64 could not be obtained. Number 2, we have to set up our own reading problem from these words. The difference between means to subtract these two amounts. The difference between 6 times a number, which would be 6x. A number means it's a variable, so x or n, whatever it tells you to use. And 7. So we're doing the difference of 6x and 7. So and is the conjunction that tells you what to do the difference to. So difference means subtract of this and this. Is, there's our verb, is equal to, there's our equal sign. Then 4 times the sum of. Now, anytime you see the phrase the sum of or the difference of or something of, they're saying it's not 4 directly times the number and then add 5, but it's 4 times do the sum of what? A number and 5. A number x and 5, and we're doing sum, so that means add. So that would change our words into an equation that's then solvable. And I think it's to solve it too, but I'm going to leave it at that because the main thing is getting these set up. All right, number 3. Sides of a triangle have length. So kind of out what that would look like. Some sort of triangle, two the same. The third side is 6 less than twice the common length. All right, just picking on us there, I guess. 6 meters, so it's in meters, 6 meters less than twice the common length. Common length is referred to in this, and we don't know what it is, so I'm going to call that my unknown, basic unknown, I do even say, kind of the building block. These two sides, they're the same, so I'll call them both that unknown x. And then this third side is 6 less than twice. That looks like this, 6 less than twice that length. Now remember, when they use the word less than, you put it in the back. It kind of reverses the order. It's 6 subtracted from 2 times that whatever. The perimeter of the triangle is 10 meters. Perimeter means distance around, adding up the 3 sides. So side plus side plus side. Perimeter is 10 meters. And you can kind of drop the meter part. The m part is just the units it's measured in. But anyway, that's a solvable equation. 1 plus 1x is 2x, plus 2x is 4x. Then move the 6 across. 4x is 16. Divide both sides by the 4, and we have a solution. Now we know these two sides were each 4 meters. So we can figure that out. Those are each 4, and this is 2 times 4 minus 6. What's 2 times 4 minus 6? 8 minus 6, or 2. And that works. Notice 4 plus 4 plus 2 does give me the right 10 meters. We can check that out. All right, it looks like we get to do a similar one. I think 4 was very similar, so I moved to number 5. The second side of a triangular disc is 5 feet longer than the shortest side, and the third side is 5 feet shorter than twice the length of the shortest side. Notice how they referred to shortest side twice there, so that seems like a major building block here that I would call my X. A lot of times in the reading problem you might have to read it a couple of times, but you'll hear what that basic unknown is, what you need to build around. And I'm going to say is that short side. And it also kind of helps me to draw a picture. And I've got the short side, which I didn't really draw it, so it had, it looks like almost they're all the same, but just to give me something to figure on, I'm going to call it the short side. Then the second side is 5 feet longer. So let's call that side the second side, 5 feet longer. And then we got another side. The third side is 5 feet and twice the short. 5 foot short. It's going to be minus 5 from twice the length of the short side. Remember, the short side is that x. Twice that. So we're able to represent. And these are just kind of like brain teasers to help us get our brain kind of going with this idea of building equations. Then it tells me the perimeter is 48 feet. So perimeter means add up all the sides. So x in any order plus x plus 5 plus 2x minus 5 equals 48. And this one's in feet, notice, although we don't put that in the equation. X and 2x can be combined. 5 and minus 5 cancels out. Then we divide by 4. And we learn that x is 12. So 12 feet is the short side. Then we can figure out this one is 12 plus 5. That would be 17 feet. And then lastly, 2 times 12 minus 5, or 24 minus 5, 19 feet. And then check it out. It's 12 feet plus 17 feet plus 19 feet should be our distance around our triangular deck of 48 feet. All right, so the next one we're going to move to, we see this a lot in algebra books and their mixture problems. I kind of mentioned it earlier on. And we're mixing two concentrations. Let's see, we got a 50% concentrated antifreeze and a 30% concentrated antifreeze. So we know they're going to come out somewhere between 30 and 50. And this one we want it to come out exactly at 40% antifreeze. It helps me kind of to show as buckets maybe or containers. If you've got this bucket plus we're going to mix it with this bucket and then we're going to pour those together into our big bucket, our result bucket. So you've got an amount and a percent, how much is in it, the amount and what's its concentration, added to another amount percent, and you need to equal a certain amount and percent in the final amount bucket. So amount and percent. And it kind of tells you in the problem what to put down each one. But is how much, so we don't know the amount, and it is of a 50% concentrated. It's antifreeze to give you something real to think of, a freeze solution. We're going to mix it with, so there's our plus sign. In this bucket, we've got the amount known here is 80 gallons, and it's 30% concentrated. Then we're going to get, so there's our equal sign in our result bucket. It needs to be 40% concentrated. Now, in a lot of these, it doesn't tell you the amount because we can figure that out on our own. If we poured this bucket and this bucket into that bucket, the amount is the x and the 80, x plus 80, and that gives us our amount in our result bucket. It's not written out per se in the equation, but we deduce that from understanding we're adding these two amounts together into this. That's basically your equation. You multiply your percentage, which needs to be changed to a decimal. Always change to decimal form when you put something in an equation. Then the amount times the percent. And it kind of told us that up here when we use the word of. That means we're multiplying. The amount multiplied by the percent will tell you the exact amount of antifreeze that's in that bucket. So anyway, you multiply these two together. 50% of x plus 30%, which is 0.30 or 0.3 of 80, to get 40% or 0.4 or 0.40. I'm just dropping my extra zero there of the total. Now you've got an equation. To save time, I'm going to just say that's how you set up the equation. Then it's up to you to use some of the strategies we've been learning to solve from there. You could clear the decimals if you wanted to and times by 10. Move the decimals back out, or times by the 100, which almost it puts you back to where you were originally. In this one, just because it's kind of a special case where you have a percent in all three parts of your equation. You'll see that on these mixture problems. They're kind of all like that. Okay, number 8, let's do it again. We've got another mixture problem, then another one, then another one. Lots of these. They're kind of a standard algebra thing that comes up a lot. Application, the mixture problems. This one says how many quarts? So much, and it's pure is my key word there. Pure means 100%. So we're going to know 100% antifreeze, pure antifreeze bucket. We're mixing it with, so we're going to make this one strong. We're mixing in stuff. We're going to add it to 9 quarts is the amount, and it's 30% concentrated to obtain or to get, there's my equal sign, 40%. 40% of what? You have to have an amount here, and it's these two amounts added together. That's basically your equation. 100% would move 2 left and be 1 times x, 0.3 or 0.30 times 9 to equal 0.4 times the x plus 9. And then we solve that for our x. Number 10, another mixture problem. So we've got our bucket plus our bucket to equal our result bucket. Each one has an amount percent, right? How much water? So how much means we don't know the amount. And water shouldn't have any chemicals in it. You might debate that with me, but we're going to assume no antifreeze, no alcohol solution, none of these things we're talking about. We're going to assume it's 0% of whatever chemical we're talking about. So how much, if it says water, we're going to put 0%. We're going to add that to, so there's our plus sign. Here's an amount in the next bucket, 22 milliliters, so a little tiny bit, of 18%. So our percent is 18%. To get, or to reduce to, the concentration to, so our result bucket is 11%. And how of what? You always have to add these two amounts, x plus 22. That gives us 0 times x, just a big 0 there. 18% of 22 to equal 11% of x plus 22. So you can kind of just leave that part off. And let's finish this one. Are you just curious what the answer is? Let's see if we can finish this one out. 0.18 times 22 is 3.96. And then distribute here. 0.11x plus 0.11 times 22 is 2.42. I want to solve for x, so I throw my decimal constant to the other side and minus 3.996 minus 0.42 is 1.54 equals 0.11x. Can you see that? Then divide by what's with your variable. Divide by the 0.11. And we get 14. It doesn't always have to come out perfectly even, so don't think you're wrong if it doesn't. But I did come out with a nice round number, which makes me feel like maybe that's right. But that's what I need to put right there. I need 14, and it is in milliliters. 14 milliliters of water will reduce that down, or sort of water it down, I guess you might call it, to the right mixture. All right, now we're moving to money. Our last two questions are with money. They're very similar to what we did. We're going to mix money accounts, so maybe I'll think of these as being bank accounts or money bags. So we've got some money in an account plus some more money, and we're trying to mix together to get our output of money. So we're mixing accounts. This example has Ralph Chase plans to sell a piece of property at $160,000. Then he's going to split the money, but not equally. That'd be too easy, right? We do 80 and 80, but he doesn't do it that easy. He splits it to be paid off in two ways. A short-term note at 10% interest and a long-term note at 8% interest. Find the amount in each note if the total interest paid is $14,600. That's our result bucket, or our result amount. So we want some interest in this account plus some interest out of this investment account to equal our total interest. So this one is already in interest amount form. So it's not an amount percent thing in this one. It's just already in the right form. But in these two, I have to have principal times rate times time. PT equals simple interest. Well, how much principal is in this first account? Tell me actually either one of these, so I'll call this X. And I'll call this one $160,000 minus whatever I used up over in this account. I don't know one really. Then the rate in the first account, and it doesn't really matter which one you call which, I'm going to do 10%. And the other one is at 8%. And then the time part is annual interest paid. So we're assuming annual means 1 year. So PRT, multiply all that together, that's 0.10x. Multiply all this together, 0.08, and then times 160,000 minus x. So that's the interest in that account. That's the interest in that account. Needs to equal $14,600. That was our clue, and then we would solve from there. I'm going to stop the video, come back in, and finish solving that.